Let's take a look at this chart to see how our IPv6 address is being allocated. You can see the color code accordingly. Okay, it starts off with 2000:/3, and INA will allocate blocks of /16 to the regional registries. The regional registries, as you can see here in brown, okay, will allocate blocks of /32 to the local ISP provider. And the local ISP providers will allocate blocks of /48 to the end sites or the customers. Their customers may subnet this address space right up to /64. Okay, so you can see that from /48 to /64, these are the number of bits, okay, that can be subnetted. Anything that is beyond 64 is untouchable because it comprises of an interface ID, which is formed from the 48 bits of the MAC addresses of that device. The IPv6 addresses consist of 128 bits, 16 octets divided into 8 groups, meaning to say that each group will have 2 octets and they are separated by colons. Each group, 2 octets there, will have 4 hexadecimal characters. Each hexadecimal character represents 4 bits. This is an example of IPv6 addresses. It consists of 8 groups, 1, 2, 3, 4, 5, 6, 7, 8. And each group there has 2 octets of 4 hexadecimal code. Each hexadecimal code consists of 4 bits. There are some rules to follow to simplify an IPv6 addresses. Rule number 1. Preceding zeros can be omitted. So for example, 0db8 can be written as db8. 00A1 can be written as A1. And 0001 can be written as 1. Okay? So, this is another example over here. 0db8 can be written as db8. 0090 can be written as 90. And 0000 can be just written with 10 to represent all the 4 zeros. Here is another example. 4 zeros represented by 1 hexadecimal. Rule number 2. Consecutive zeros or consecutive fields of all zeros can be compressed using a double colon. Now the first 2 examples here, the IPv6 address strings do not consist of any consecutive zeros. The third example, we have 1 set of consecutive zeros, so we can represent it by a double colon over here. Now the fourth sets, we have 2 sets of consecutive zeros. Does that mean that our IPv6 address strings will have 2 double colon? The answer is no. So we can choose to take the first set to be represented by 00, or alternatively, you can choose the second set here to be represented by double colon, and the 00 in front remains the same. Rule number 3. In one IPv6 address string, we can only find one double colon, as what we have shown over in the previous slides for example 4. Here, we have two sets of consecutive zeros. So, can we represent them with two sets of double colon? The answer is no. This is a wrong IPv6 format. IPv6 address with port number representation. Now, can you still recall in IPv4 transport layer, how do we represent our sockets? We put in an IPv4 address followed by a colon with a port number. So, it cannot be done for IPv6. If you wish to use a colon followed by port number, then you need to use a square bracket to close up the IPv6 address. As stated down here, it's not recommended to be done the same way as your IPv4. Or alternatively, you can just state down your unicast or your global IPv6 address and then with a dot followed by port number, or if not, then simply put in your IPv6 address and then key in port 80. Or if not, just put in P80 or hex 80. IPv6 prefix notation. IPv6, as we know, has 128 bits for IPv6. So, the notation can be /32, that will create 4 million over subnets, or /48, that creates 65,000 over subnets, or /52, that creates 4,096 subnets, or /60, that can create 16 subnets. Now, in this case here, we have to leave the last 64 bits there as the host address of this IPv6, because this last 64 bits here is our interface ID, meaning to say that your subnetting cannot exceed over /64. Like what I've mentioned, IPv6 has a total of 128 bits. And I have mentioned that we cannot touch the last 64 bits because the last 64 bits there represents the host address. So, as we know, IPv6 has 8 groups in there. Altogether 16 octets. So if we split up the 8 groups, okay, then this will be the 64 bits, the last 64 bits. And the front here, the first 64 bits. So the last 64 bits there represents your host address, who am I? And the front 64 bits there represents your network address, where am I?